Assalamualaikum and good morning to all.
Good morning, Nathan.
Waalaikumsalam, Doctor.
Salam, morning.
So how are you? So I think this is your last class before the semester break, midterm break.
Yes.
Okay, thank you. Alright. Okay. So for this week, we will proceed wherever we have need to continue lah. Regarding to the topics for this contract unit 2. Where is it? Okay, I will try to make it this class finish as fast as possible. Since at 11 a.m. I have some others work such as interview. So hopefully everything will going well. So we try to finish this today topics regarding to whatever the slide that I uploaded to the Google Classroom yesterday. Okay. Right. Regarding for the previous week, we already talked about the system learning part 2. Before that, I teach you how to convert electrical system to state space. However, on during last week, I convert the system from mechanical to state space. So this is what we have done. I believe everything has finished because last week do the modeling for the mechanical system to state space, and then after that I already show you how to convert the state space to the MATLAB Simulink. Okay, so please refer to the video in order to prepare for your lab. Okay, so far we already in this state, so everything is finished, done. And then I give you some examples, and also finally there is also exercises that you can do. Yep, convert to state space form, exercise, and so on. Hopefully you can try these exercises, these questions in order to obtain the answers given. And then finally also I give you a link. Okay, this is the link that you can refer to get more exercises, examples. So this link is referred to the textbook. Okay, done for this first part of first topic. Okay, so now for today, still loading. For today, I will focus on to convert from state space to transfer function. Now we already know the system when convert to the state space. Now we want to find the relationship between control 1 and control 2. State space, control 2. Transfer function, control 1. So we need to find the relationship between these two causes. Okay, in the previous topic, the student you have learned about the state space structure, check, do the modeling of the dynamic system, which is convert the system, electrical and mechanical, to state space form, check, and then state space to transfer function. So now we add this side, state space to transfer function to state space. However, number 4 and 5 already done lah. So in this topic, the student will learn about the conversion between state space and transfer function, the analysis of the conversion system, and finally the determination of agent values and agent vectors. So what is the agent values? So what is the agent vectors? So these are keyword lah. And then for today, I will show you how to do these two. The conversion between state space and transfer function, number 1. And number 2, the analysis of the conversion system. So what do you think? What is the type of analysis that you think you will learn today? The analysis of the convolution system. Anyone would like to give me any answer? What type of analysis? The common analysis. When we have a system, when we have the transfer function, what is the common analysis that we will do? Mio, what do you think, Mio? Nuri Amni, what is the type of analysis, Nurin? The common.
To check stability.
Yes, no, that's correct. So for today, we will check the stability of the system. Lah. Okay. So now we have the state space, and then you convert to the transfer function, and then you see, is it the system stable or unstable? Okay. All right. So at this part already done. So now we focus on this area to convert the state space to transfer function. So today we just focus in this area only from state space to transfer function. After the midterm break, I will focus on how to convert the transfer function to state space. Yep. Datang. Okay. Alright. So this is our focus here from state space to transfer function. And this is after midterm break. This one after midterm break. Okay. So I would like to classify the state space and transfer function characteristic. The state space in time domain, and this is the form of the state space: x dot equal to xt plus but, yt equal to cxt plus dut, and then transfer function in frequency domain. Okay, and then the formula for the transfer function is the output divided by input. Output divided by input lah. Okay, so as I mentioned earlier, I would like to teach you in this area for today's class to convert the state space to transfer function using this formula. This is the formula you will use in order to convert the state space to transfer function. This is the formula. Okay, you can see that C, A, B, D, because we have C, A, B, D. So you need to use all this information, and then plug into this formula in order to obtain the transfer function. Okay, so this area we will cover after the midterm break to convert the transfer function to state space, and then it can convert it into a few forms: PVF, cascade, parallel, CCF, OCF, and so on. Okay, so today we just focus on this area. But why we need to use this formula? Why there is no other than formula other than this? So why we can obtain this formula? So we just look at this derivation. Okay, so converting from time domain to frequency domain. So now we have the state space in time domain. So in order to get the transfer function, we need to Laplace it, because from time domain to frequency domain, so that's why we need to Laplace. So that's why we take the first equation of the state space, x dot t equal to xt plus but, and then we target to obtain the output divided by input. So this is our target, because the transfer function. Okay, so now we have x dot t equal to xt plus but. then we need to Laplace it. So xt become sxs, axt become axs, but become bus. And then after that, we just collect xs together and then equal to bus. So why this part? Why this part? Sxs, when we factorize the xs, become sy. Why? Why sx? This one okay. Axs, we factorize xs become a, is it? But why in this part, sxs, we factorize become si? Okay, so we need to know why. Okay, would like to ask Ahmad Abiza. Okay, Ahmad Abiza. I give you a hint. Actually A, B, C, and D. Actually, in what form? Ahmad Abiza. So you know that A, B, C, and D in what form?
State space.
Yes, state space, but A in what form? You know that A, you have A. A equal to what? What is the form of the A?
Matrix.
Matrix. That's correct. Okay. A in a matrix. Okay, matrix form. So that's why if you want to factorize something, okay, that's why when you factorize this part, it become Si. Okay, because this is a matrix form. Okay, because S just a S. Okay, A is a matrix. If you have S, if you didn't have I here, S S is just an S minus a matrix, you cannot obtain, you cannot solve the equation because S minus a matrix, no, you cannot do it. If you want to minus a matrix, you must have a matrix with the same dimension with A. So you have the same matrix dimension of A minus matrix of A, you get the answer. However, if you have only S minus a set of matrix, no, you cannot solve it. So that's why we have need to put I here. The I here we call as identity matrix. Okay, I just put it here. We name it as the identity. Oh, I actually put it there. Okay. I is the S. I is the identity metric. S is the frequency domain. Apa saya tulis ni? Tapi error ni with the identity matrix. Okay, so clear why we need to put I in here. And then after that, you finally obtain xs equal to si minus a. Because this is matrix, okay, if you want to move it there, so it become si minus a inverse because this is matrix. So xs equal to, you need to move it to the right, you need to put negative inverse, okay? So next, from yt equal to cxt plus dut, same again, you just Laplace them, become ys equal to cxs plus dus. And then finally you have equation 2, you just move to equation here. Okay, and then finally the xs equal to this part. Okay, this is xs. Okay, and you factorize US, and finally you got CSIA inverse B plus D. So finally you obtain this is the formula to convert from state space to transfer function. This is the formula. Alright. So firstly, before we can use this formula, you need to know, you can see that Si minus A inverse, there is inverse here. So you need to know how to do the inverse in matrix before you can solve the question. So knowledge that you must have before can convert state space to transfer function, you must know how to do an inverse matrix. And then you are familiar with matrix operations such as summation, subtract, multiply, and do the divide. Okay. So, okay. So in here, I already uploaded 2 examples in how to convert, how to do inverse two-dimensional matrix, and how to do conversion to inverse three-dimensional matrix. Because normally in your exam question, I will use up to third order three-dimensional matrix only. Okay, so that's why you need to know this thing. Okay, so let's see how to do the inverse two-dimensional matrix. Okay, so how to solve for inverse matrix using? So the formula for the inverse matrix is, this is the formula to do the inverse matrix. If you have A here, you need to adjoin A divided by determinant A. This is the formula to do the inverse. So you need to find what is the adjoint A, and also you need to find the determinant of A. So this is a technique that I developed by myself. To calculate the adjoint, you remember this 3T. Okay, 3T technique. Okay, in order to find or obtain the determinant of A, you need to remember 2T techniques. Okay, for adjoint, 3T technique is mean that you need to follow these 3 steps of T. Firstly, you need to do transpose and tutup and tanda. Transpose is mean transpose. Tutup is mean close in English. Close, yeah. Tanda is sign. Transpose, tutup, tanda. Transpose, close, sign. Okay. While the determinant of A, 2T technique, tutup, tanda. So it's mean that close and sign. So we need to solve it one by one. Adjoin A first using the 3T. Yeah? This is the question. A matrix is 1, 3, 2, 5. Okay, firstly, you need to do the transpose. So 1, 2, 3, 5. After you transpose, become the row become column. The row become column. Okay, so 1, 2 become 1, 2. 3, 5 become 3, 5. Done for the first step, transpose. And then after that, you tutup. Tutup, yeah. So if you want to fill up the at this part, this is let's 1A location, 3B location, number 2 here is C location, number D is 5 location. So let's say if you want to fill up this value here at, you refer A, refer A, you want to fill up the value here. besar lagi tak boleh. Tak boleh besar lagi. Okay, if you want to fill up here, so you need to tutup. Tutup here. Tutup 1. And then you cross 1 and 2. See what is the number left. The number left is 5. Okay, so now we want to fill up this area. We need to close this area. So you need to find the vertical and diagonal of the number that we want to close. And then what is the number left? 2. Okay, 2. And then we go to the third number. We want to close number 2. So you need to look at the vertical and horizontal. The number left is 3. And finally, we close the last number, 5. And then we just find across all the numbers that vertical and also horizontal to the number 5 become 1. So now you can see that 5, 2, 3, 1. So you just put it in this place, 5, 2, 3, 1. Done. Second step, tutup. Okay. Finally, we go to the final step, tanda. Tanda is a sign. So remember this pattern. The pattern must be positive, negative, positive, negative, negative. This one. This is the pattern. Since this is 2 by 2 matrix, so you just need to crop 2 by 2 matrix only in here. 2 by 2 matrix in there. So the number you have after tutup, 5, 2, 3, 1. And then you overlap the sign into the tutup output. And you get, this is 5, positive 5, negative 2, negative 3, positive 1. So you got 5, negative 2, negative 3, and 1. So finally, the adjoint of A you obtain is 5, negative 2, negative 3, and 1. This is the adjoint of A. Just remember these 3 steps, transpose, tutup, and tanda. The tanda, you need to remember this pattern. Okay, so now done for the adjoint A. We need to proceed with the determinant of A. The determinant of A using 2 T techniques, tutup and tanda. So just remember the determinant A, tutup, tanda. Okay, tutup. Choose only one row or column from A. In this case, I would like to use this row. I choose 1, 2 row. You can choose 1, 3, no problem. You can choose 2, 5 also. The combination of 2, 5, okay. You can choose 3, 5. Depends. You can choose any row or column you like. Okay. So I choose 1, 2 row. So I put it 1 here and put it 2 here. 1, I put it here, 2 here. And then as usual, since I choose 1 and 2, so I just need to tutup only 1 and 2 only. So after I tutup 1, the answer is 5. And then after I tutup 2, the answer is 3. So in here, since I choose 1 and 2, so after I tutup 1, the answer is 5. 5 refer to A. After I tutup 2, the answer is only 3. It means B. So what I need to do, I just 1 multiply with 5, 2 multiply with 3. But I don't know what the sign that I need to put. Is it negative, positive, and so on? You just need to remember this pattern again. Okay, since we choose this area, 1 and 2 area, so just remember that 1, the sign is positive, and 2, the sign is negative. So that's why I put positive and negative. And finally, we get the determinant, we solve this. 5 minus 6 become negative 1. So finally, you just plug into the formula adjoint A divided by determinant A, and finally you got this answer. So the inverse matrix of A, finally you obtain -5, 2, 3, -1. Okay. I believe in for sec 2 by 2 matrix, you have a simplest way to obtain the answer. However, how about the 3 by 3 matrix? It's quite difficult. So if you follow this 3T and 2T techniques, I believe you can do it easy. No, easy peasy. So next, we just go to the second part. For the second example, how to convert 3 by 3 matrix. I believe you can say that by using this number, I just can use calculator to obtain the answer. Okay. However, for control 2, you cannot use calculator to obtain the answer because your A matrix not only have number but have some parameters, S parameter. So you cannot use your calculator to inverse matrix of S, a matrix with S. So that's why you need to know this technique in order to convert a matrix to the inverse matrix. All right. So we just will go faster for this part. Let's say this is your A matrix. You need to find the A inverse of this matrix. So as usual, the formula is adjoint A divided by determinant A. And then after that, you need to find what is the adjoint A. After settle, you need to find the determinant of A. Okay. Firstly, transpose. So you got the transpose matrix of A. And then after that, okay, and after that, you need to close. Close one, you got 1102. This is the reminder of the value. And after that, you need close two. And then 0112. And then you need to close this part. You need to follow the step by step lah, one by one lah. Because this is 1, 2, 3, 3 by 3 matrix, you will have 9. 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. You just do it. Okay. So after that, you just arrange everything here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then put all the remaining metric you obtain. Okay. And then in order to find the value, you just need to remember this pattern. Okay. Starting from A here. Okay, starting from here. 1, 2, 3. Remember this pattern from A to C, D to B. So you just remember A to D. Okay, the start point here, follow and end this part. Okay, so you can see that A multiply with C, A multiply with C, and if you go, this is the diagonal direction, A to C, you need to multiply, and then if you go up, you need to minus D multiplied with B because the diagonal value. So it become AC minus DB. AC minus DB. Okay. So in this case, you can see that the first number 1 multiplied with 2 minus 1 multiplied with 0. So this one multiplied with 2 minus 1 0. So after you get all this value, and finally you got this is the value after you tutup. Okay, after you tutup, this is the value. And then after that, you need to put the sign because this is 3 by 3 matrix. You need to crop this area pattern. So after that, you just need to from this and apply the sign. This is your adjoint of A. Okay, this is adjoint of A. And then after that, you do the determinant of A. You use this formula tutup tanda. Okay, in this case, I'm happy to use the row or column with 0 because it was easy for you to calculate. Okay, so in this case, I choose the row of 101. 101. And for sure, you need to close 1 first. And this is the remaining matrix. And then you close 0. This is the remaining matrix. And then you close 1. This is the remaining matrix. So 1012, you put 1012, 2012, 2012, 2111, and after that the 101, and after that put the tanda. This is the row that we choose, so we need to put positive here, negative and positive. Why I love to use 0, because this, if you look at number 2 here, everything multiplied with 0 will become 0, so you don't need to calculate. So that's why finally you got the determinant is 3. And plug into the formula. So this is the inverse matrix of A, 3 by 3 matrix. Okay, so far, how is it with your with the how to find the inverse matrix? Muhammad Ali. How is it, Muhammad Ali? Abdul Rashid.
Yes, Doctor.
How is it for the inverse matrix conversion? Is it easy to follow or difficult?
So far, can follow, Doctor. Can.
Godri?
Boleh.
Alright, Lavanya?
Boleh, Doktor.
Okay. Leong. Leong Zichong.
Hi, Doctor.
Alright, okay.
Yeah, okay. Since most of them we learned before in the max.
Yes. So because this is really crucial, if you cannot do this to do the inverse matrix, you will have difficulty in order to do the controller implementation. Because the controller implementation, you need to have this knowledge in order to implement controller to the state space system. All right, so we proceed with the lecture. Okay, so we already show you how to do the inverse matrix for the 2-dimensional and 3-dimensional matrix. So now we go to the example lah. Obtain the transfer function for the system below. So you need to identify your A matrix. You need to identify your A matrix, your B matrix, your C matrix, and also your D matrix. Okay, after you identify, you just need to plug in your matrix C, A, B, and D into this formula. Okay, so firstly, this is the step you must follow lah. Okay, you need to find Si minus A first, because you can see Si minus A inverse. So in order to obtain Si minus A inverse, you need to find Si minus A first. What is Si minus A? Since A matrix is 2 by 2 matrix, so the identity matrix is this one. Okay. So note, if A matrix is 3 by 3 matrix, this is the identity matrix. So you can see that the identity matrix, the value 1 diagonal, the rest will be 0. So this is the identity matrix. Okay, so now we need to find Si minus A. This is S, this is I minus A. So why we need to have identity matrix? Because let's say if you didn't have identity matrix here, you cannot do S minus this matrix. No, you cannot solve. You cannot solve this part. No, you cannot solve it. So that's why you need to have the identity matrix. Okay, so now this is Si after you multiply them together minus A, and this is your final Si minus A. After you obtain Si minus A, this is your Si minus A. Again, okay. This is your Si minus A. And then you need to find the Si minus A inverse by using this formula, adjoint divided by determinant. So the adjoint of Si minus A, this is the answer. How you want to get the answer? You use the 3. How you want to, Abdul Rashid, how you want to find the adjoint Si minus A? What is the technique that I told you? Abdul Rashid? What is the technique? Abdul Rashid, are you there, Abdul Rashid? Tak ada. Ahmad Aiman. Triti. Okay, thank you. Okay, so we need to use the Triti. So let's say if you have Si minus A, okay, and then you need to transpose it, so it become S minus 2, 1, negative 3, S plus 4. Okay, you transpose them, and then after that you need to close. That's why you got S plus 4 here, and then you need to close negative 3, so that's why it become 1, and then you need to close 1, and you got 3, and then you close S plus 4, become S minus 2. However, you need to apply the sign positive, negative, negative, positive. That's why you got this, the answer of the adjoint Si minus A. Okay, after that, you need to find the determinant Si minus A by using the 2T technique. And this is the answer for the determinant Si minus A. So that's why you cannot use calculator, because the Si minus A in S. So that's why you cannot use calculator. Okay, thus at the end you obtain Si minus A inverse. This is the answer. This is adjoint divided by the determinant. And then after that, after you obtain Si minus A, you just plug into the formula lah. This is C, and this is Si minus A inverse, and this is B plus with D. D is 0 lah. So you can take out, move the determinant to the front, and less the matrix only. Okay, finally, after you solve these 3 matrix, you got, this is the transform function. S plus 5 divided by S squared plus 2S minus 5. Okay. I want to ask Cheng, Pangzi. Okay. What do you think about this system? Is it stable or unstable, Cheng? Okay, how do you tell the system stable? The system is stable, check. You answer stable, but how? How do you determine the system is stable? Anyone would like to give answers other than Chang? Chang said the system is stable. Check the poles and zero. Okay. I still like to remind you that to check the system stable or unstable, we just look at the poles only. Poles on. Okay, Ruslin. So your answer is there. Okay. To check the system stability, you just look at the poles only. Okay. We did not look at the zero part. We look at the poles. Yep, that's correct, Ruslin. Okay, so in this case, the post located at where? Is it on the left hand, all the post at the left hand side, or you can find some posts on the right hand side? What do you think? Anyone can answer? Using microphone. Also, you can write your answer in the chat box. How is it? Okay, I give you some times to calculate the post location.
System is not stable, okay?
Once again, unstable.
Yes, unstable
Why unstable?
because one of the poles is at the right hand side of the screen.
That's correct. So you can see that. Please make sure when you do calculation to obtain the post, please make sure the sign carefully. Okay, the answer is correct. The system is unstable. See, yeah. In conclusion, if you have this kind of the state space, and this is the transfer function you get. Okay, based on our derivation. So in this case, in order, this is what we call as a characteristic equation. The characteristic equation determines the stability of the system. And then note, the characteristic equation generates by determinant S minus A only. So let's say in a question, let's say if you are given this state space, and then the question is determine the stability of the system. In order to answer the question, you not need to use this formula. Waste of time. Because you know that the part that will determine the stability of the system only this part. This part is the characteristic equation. And then the characteristic equation only generates by determinant of S minus A. So what you need to do, you can see that according to the previous slide, you can see that s square plus 2s minus 5, s square plus 2s minus 5 is equal to, it contributes by determinant si minus a only. So in this case, you not need to calculate adjoint, you not need to plug in the formula in order to obtain the stability of the system. You just calculate determinant si minus a only. So that's why in this case, this is characteristic equation, determine the stability of the system. The characteristic equation generated by determinant Si minus A. So according to my previous experience, most of the students waste their time by plugging everything, C, A, B, and calculate everything in order just to calculate this to determine the stability of the system. However, they just can straight away use this determinant Si minus A. Okay, so in conclusion, we can say that the location of 0 is -5 and pose is 1.5 and negative 3.45. Carefully, Muhammad, about the sign. The sign is really important.
Yes.
Okay. Hence, the system is unstable because there is a pole located at the right hand side of the S-plane. Okay, so 1.5 lah. Okay, now we go to the second example. This is 3 by 3 matrix. 3 by 3 matrix. Because the question asks you to obtain the transfer function, so you need to use the formula lah, CSI minus A inverse B plus D. Okay, if the question determine the stability of the system, you just calculate determinant SI minus A only. Okay, as usual, you need to know lah your A matrix, your B matrix, your C matrix, and D matrix. Okay, after you know your A, B, C, and D matrix, just plug into this formula. Okay, as usual, you need to find Si minus A first. Okay, since A matrix is 3 by 3, so this is your identity matrix. And then you just plug in to this formula as I minus A equal to this thing. I just want to remind you, please carefully when you do the SI minus A, because most of the student forget to put the negative sign here. Okay, because 0 minus 1 will be, because 0 minus 1 become negative 1, because they not do it carefully. Sometimes they forget to put negative sign and so on lah. So this is really you need to careful lah throughout this process. Do it carefully. Okay, done. You got Si minus A. After you obtain the Si minus A, and then the Si minus A inverse is adjoint Si minus A divided by the determinant of Si minus A. So firstly, you need to calculate adjoint S minus A, Si minus A. This is the answer lah. And then you need to find the determinant Si minus A, and this is the answer. So please do it by yourself until you can get the similar answer for adjoint S minus A and determinant S minus A. If you cannot produce the same answer, please keep trying again, because you really need this knowledge, this fundamental, in order to convert the state space to transfer function. Okay, finally, you get Si minus A inverse this thing. Okay. So after that, you plug into the formula. This is C. This is Si minus A inverse. And this is B. And finally plus D. Since D equal to 0, so this is your transfer function. Okay, I give you a hint. I give you a hint to make you, I give you a tips in order to make faster to solve this kind of the question. All right, so you know that your C is 1, 0, 0. So in this case, everything multiplied with 0 will become 0. Everything multiplied with 0 will become 0, is it? So what you need to know, this area matrix. This area matrix, you will multiply with this part. Okay, the rest, 0 will multiply with this part. So everything will become 0. And 0, this one 0, you just need to multiply with this part, become 0, is it? So that's why you don't waste your time to calculate this part. No need. No need to calculate this part, because everything here will become 0. So finally, sorry, I just control that. This guy. Okay, I need to open it again. Okay, so this part, This one multiplied with this, multiplied with this, multiplied with this, is it? Okay, this part multiplied with this, and second, third. So you can see that here everything is zero. Everything here is zero. So these two parts will multiply with zero, zero. So what you need to know this area only, because this area, okay. And then after that, this part will multiply with here, here, and here, is it? So the only, and this part also need to multiply with zero. So what you just need to know, highlight only this area. Highlight only this area lah. So you can see that s square plus 3s plus 2 multiplied with 10. So that's why you got 10s square, 30s square, and 20s square. Okay, and then multiply with 1. So that's why you got this thing. So this is the faster way lah. So as you know, this is contributed by the adjoint Si minus A. So you know that the rest is useless. Multiply with 0, is it? The rest is useless. You just need only have this formula, this information only. So when you calculate the adjoint minus Si minus A, you just need to calculate this value only. The rest you just skip. You just skip everything here. No need to calculate. No need to calculate. You just need to calculate this area. So you will save your time lah in order to solve the question. Because everything here you just will multiply with 0. So it will be waste of time. Okay, just need to calculate this area for adjoint Si minus A. Okay, maybe I can show you lah what's the meaning of that. So in control system, you need to have some strategies in order to help you make your life easy to solve the question. So you can see that this is Si minus A. Now we want to calculate adjoint Si minus A. As I mentioned earlier, you need to transpose as -1, 0, 0, as -1, 1, 2, s plus 3. Since I told you that this is transpose, and then we need to tutup, because we just need this information here. So we just close here everything. So the rest only have s 2, -1, s plus 3. And then remember that I told you that we need to use this pattern. This is start, and then this is end. Okay, start end. So you just finally you obtain tutup, and then after that tanda positive, negative, negative, and positive. Okay, so finally you will get s multiply with s plus 3 minus with this one become positive, positive 1 multiply with the -2, and you got s square plus 3s plus with 2. Okay, so you got this answer. The rest you not need to calculate. No need to calculate. And then after that, you just name it as A, B, C, and so on. You just put it in the formula, and finally you obtain the answer. However, you just need to know lah which one you need to calculate. In this case, you know that you need to calculate here only. So this is your transfer function. Okay, so according to the question, so this is your state space, and then you convert to transfer function. And then after that, you can determine the stability of the system by looking at this characteristic equation. So the characteristic equation determine the stability of the system. So note the characteristic equation generates only by the determinant of Si minus A. So the location of pole 0 is -1, -2, and then the pole's location here. Hence, the system is stable because all the poles located on the left-hand side of the S plane. Okay. So there are two exercises for you can do. Exercise 1, exercise 2, and then this is the answer. Please try to solve the question lah and obtain the similar answer they provided. Okay, so in control engineering, what I like to mention you again, you need practice a lot, practice. Okay, so please you can solve this question by using the long way. Just put everything in the formula, or you can use the shortcut way lah that I just mentioned before. Okay. So I believe in order to convert state space to transfer functions is really easy. Just use the formula here. Just use this formula. After you use this formula, make sure you know how to do the inverse of matrix. Si minus A inverse. This is the crucial part in order to convert from state space to transfer function. Alright. I think that's all for the class today. Before we leave, I want you to wait a minute. Please fill up the attendance form. I publish in the. Hari ni ramai tak datang. More than half, around half of the students did not join the class. It's okay. I'm okay with that. Okay. However, just look at your final result lah during the after end of the semester. Okay. So I would like to wish you all selamat Hari Raya Aidilfitri and maaf zahir dan batin. Eid Mubarak, and please be careful lah. Tempat diorang raya awal. Okay. And then please careful lah during this Hari Raya. Okay. Hopefully, I would like to seek for apologize if any during the previous semester and this semester. Okay. So what you need to do, just fill up the attendance form, and let's say if didn't have any, you can leave the meeting. And finally, selamat Hari Raya Aidilfitri and maaf zahir dan batin. Okay, see you guys after the meeting break.
Doktor boleh resend tak?
Tanya ni, saya nak kuatkan sikit suara ya. Apa dia?
Resend balik doktor, saya tekan keluar tadi.
Oh,
terus
ya.
hilang.
Oh, dah. Okay, selamat raya semua. Okay, Godri, dapat?
Okay, dapat. Thank you doktor.
Alright, sama-sama.
Tiga tahun mana doktor?
Selamat raya. Ini baru boleh kita beraya, semalam tak dan.
Thank you doktor, selamat raya.
Okay, sama-sama.
Thank you doktor, selamat raya.
Alright. Berhati-hatilah di jalan raya. InsyaAllah.
Thank you doktor, selamat raya.
Sama, selamat raya.